And maybe the entire November team can do a refresh because I still don't see the um, share screen or share webcam. But if Team Juliet, you're ready, feel free to kick it off.
Yeah, so when we had rehearsed, we did plan to use all three screens. So I think we'll just have to take a minute to adjust.
Yeah. So again, the team that just presented, if you guys all can refresh. If not, what I can do is bring in a screen real quick, and then let me pull that back here. Whoa. And then let me make this higher. Let's see if that works for you guys. Yep. Awesome. Dope. And then
Okay.
make it a little bit bigger.
1 second, sir. 1 second. Is everyone ready?
Yep.
Okay. All right. Hello, this is Team Juliet. Our project name is Cosmic Shatter. Today we are excited to share our project focused on analyzing radio signal from space to identify a potential sign of scientific activity. So the vast amount of radio telescope data remain unstudied, creating a significant gap that limit understanding of spaceborne threat and opportunity for national defense and global security. Additionally, there are so many unknown and unanswered questions about space. So the more we analyze radio telescope data, the better we can prevent spaceborne threat. So our solution is to provide accessible and actionable data for citizen scientists, fostering a collaborative and a deeper understanding of radio astronomy, encourage a curiosity and learning environment, and also contributions to exploration of unknown. And then we will go on to talk about the UX and UI's design.
Thank you for the introduction. So looking at the screen in the middle, we have our homepage of our Cosmic Chatter. To make it more fun and entertaining, we call everyone the analyzers Cosmic Detective. And you will find this blurb of description in some of our pages to make the experiencing more entertaining and attention grabbing. So let's look at our workstation. When you click work, you get it brings you to this welcoming screen with tutorial to teach you how to analyze audio signals, and then you can explore different type of signals that we have. So we basically turn all these archive into different cards that you can look at. And for example, if you feel like this is really interesting, you want to listen to it, you can click into it, and then you can work just kind of like play around the audio, and then if you want to choose to analyze it, you can also click the bottom to analyze. You have a little workstation for you to adjust the volume, the clarity, download, share. We also have a feature of AI visualizer where when you click, it turns our audio signal into the image. Once you're ready, you can save it. It takes you to your workstation where you can see past projects, current projects, and to gamify the whole experience, we also have a progress bar here. And if you click onto it, it brings you to your profile page where you can see how you can earn more points and just personalize it a little bit more. Another feature we have is our forum. So we want to enhance a collaboration. So here's like a little space you can upload your audio or ask any questions using our AI visualizer again. Or if you want to like help answer any like questions, you can also go to the main page. Yeah, that's it for the demo.
So we go.
So I'm going to talk a little bit about the process for the tech stack on the front end. We use Next.js so that we could take advantage of The page router with server-side rendering for fast page loading with all the graphics and image loading optimization. We use Tailwind CSS to style everything. And we're using Axios for a JSON API request with the backend. And we use TypeScript for development.
Yeah, thanks, Trevor. So I'll talk a little bit about the backend now. What we had picked for a framework was Django, and I spent quite a bit of time getting familiar with the files utilized by astronomers. The file specifically is called the FITS file, and we had to find a library that would allow us to create the functionality needed for the front end, which is basically taking that FITS file and turning it into I believe the word is sonography, where you can just like play as an audio. But a FITS file is basically like just a list of data gathered by like big telescopes or like the Hubble telescope, for example, or things like that. And I think that's it. Do you guys have any questions for us?
Yeah, I have a question. I'm wondering, your target market is going to be the scientific community. Is that correct?
Not
Yes,
only
ma'am.
the scientific community, but just anyone who will love to like contribute to this, like decoding the signals and everything. So we'll have a tutorial to also teach like beginners how to do it.
Okay, so hobbyists. Okay, cool. My follow-up question to that then is, what you say you record these audios, what do they get used for?
The audios, the audios specifically, I think what she was referring to was the FIT files. So if, like, say, an amateur, what is it called? An amateur astronomer decides to take a photo of like the moon or any other galaxy or planet out there, is that they're able to upload that file and we're able to translate that into a sound or an image as shown.
And so I think also with like the FITS files in particular, they're picking up radio frequency from telescopes. So what we're looking for essentially is signs of abnormal radio signatures in the audio. So essentially what we would be looking out for is extraterrestrial life or possible other space phenomena that we're not aware of.
Okay, cool. Well, thank you so much.
Awesome, Jeff. Any last minute questions on your end?
I mean, this is really cool. So I guess on the technical side, where did you guys grab this data from? Is there just open API of a ton of, radio frequency signals out there?
Sorry about that, Jeff. Could you ask that question again?
Yeah, where did you grab the data? Is there just an API, a single API that you're able to pull from? Are there multiple sources?
Yeah, so there was data available from NASA. Then I think we used one, or we had one in specifically that we were dealing with. I can't remember the name of it, but if Kendall was here, he could tell you.
Okay.
Hello?
What would you guys implement next on top of this? So, I mean, it looks very cool. It seems like a very single player mode. What would you have done next?
Yeah, I think the idea behind it was to expand a bit more on the community aspect. I think having people to talk to about your project or your photos that you're taking would be a really helpful thing for it.
Yeah, so one of the ideas that we had was to be able to have users verified as professionals. And so then it would kind of create like a collaborative, kind of like a social media aspect to it,
Awesome. Yeah, that's kind of what I was thinking as well. Cool. Do you guys have this deployed anywhere, or is this localhost right now?
We did deploy using Vercel, but we don't have the audio portion down yet.
Okay, cool. No worries. Thank you guys. Appreciate it.
Awesome. Thank you, team. Doesn't seem like there's any more questions from the judges, but I do notice a question on the chat. So again, just like the previous teams, please post your GitHub presentation Figma file in the main Vets Hackathon channel. And then let's get Team Kilo going up next.